Consider the following parametric equations. Eliminate the perimeter to obtain an equation in x and y. Describe the curve and indicate the positive orientation. We've got the equation x is equal to 20 cosine t. Then we've got y is equal to 6 plus 20 sine t on the interval 0 to 2 pi. We're also given that the parametric equations x is equal to x sub 0 or x naught plus a cosine of bt and y is equal to y naught plus a sine of bt describe this circle. Okay, so this is the Cartesian version of a circle. Okay, so the first thing that we want to do is figure out what is our x sub 0 or x naught and what is our y sub 0 or y naught and what is our a value. Okay, so we can look at this and we can see, okay, well, in the first equation, we're given 20 cosine t, which accounts for this part, but we're not given an x sub 0 or x naught. So we'll just say that that x sub 0 is equal to 0. And y sub 0, over here, we can see that that is a 6. Okay, and then for a, that's the number that's going to be in front of the cosine or the sine. That's equal to 20. Okay, now given that, we're going to use this here, and we're just going to write down the equation of this circle. So it will be x minus 0 squared plus y minus 6 squared equals 20 squared. You can clean that up a little and you can get x squared plus, we'll leave this one as it is, y minus 6 squared equals 400. Okay, so that's the equation in x and y. Okay, now it wants us to describe the curve and indicate the positive orientation. Okay, so in order to do that, the first thing that we want to do is determine the starting point, and we're going to substitute the first value in the interval here into the x and the y in these equations right here. Okay, and then we're going to also do the plug in a 2 pi. But first, we got x is equal to 20 cosine of 0. Now cosine of 0 is equal to 1, so that's 20. Okay, and then we've got y is equal to 6 plus 20 sine of 0. And of course, sine of 0 is 0, so this whole thing goes away, and that becomes 6. So it starts at 20 comma 6. Let's see where it ends. Let's plug in a 2 pi now. So same thing we did, except we're going to put a 2 pi in there. So 20 cosine of 2 pi. And if you know your trig, you know this is going to give us the same value. That's also 20. And then y is equal to 6 plus 20 sine of 2 pi will also give us the same value of 0 on the sine part, so 6. So it's going to start and end at the point 20 comma 6. Now the question is, we can go to 20 comma 6 and we can see where it starts and ends, but we know it's a circle, but is it going to be a circle going counterclockwise or a circle going clockwise? Okay, so how do we figure that out? Well, we figured that out by the b, which we haven't talked about, but you may have seen a b pop up right here and right here. And the thing about the b, which we know our b is equal to 1 in our case because we didn't really have a b there, right? In these equations, there was nothing in front of t, so the b is equal to 1. Okay, so if b is less than 0, then it's going to be going in a clockwise direction. Okay, and likewise, if b is greater than 0, it will be going in a counterclockwise direction. Okay, so we know that this is greater than 1, or greater than 0 because it's 1. So this will be going in a counterclockwise direction. Okay, so what we know is that it starts and ends at 20, 6. So if we were to write that out 20, up 6, it starts and ends right here, and it's going to go in a counterclockwise direction. What is the radius of this thing? That's one thing that we haven't talked about yet. What's the radius of this circle? Okay, well, the radius of this circle, you can go up here where we had it written like this, 20 squared. This is r squared. So the square root of 400 is 20. So the radius is 20. Okay, so it'll be going out 20 to either side and up and down, and it'll be going in a counterclockwise direction. And that's it.